Let's continue with the previous topic, molecular absorption and emission spectra. So, the total energy of the molecule is generally a sum of potential and kinetic energy. The potential energy part of the molecule is sum of electronic, vibrational and rotational energy. The total potential energy of the molecule is generally representing electronic, vibrational and rotational energies, which are each quantized, have seen in the previous class. Now, what happens when the molecular energies are getting promoted into the higher energies? If a polychromatic light interacts with a large number of molecules, that is a given population of molecules, some of the molecules absorb a portion of the light. As a result, certain electrons within the molecules undergo a transition to an excited energy state. This is normally accompanied by an increase in the vibrational, rotational energies of the molecule. That means, if you promote the electronic energy of the molecule, which obviously promotes the vibrational and rotational energies also, the excited molecule gain different quantities of energy equivalent to the gain in electronic energy plus a large number of vibrational and rotational energies. This is the energy diagram, Jablonski energy diagram. So, this energy diagram explains various energy states that a molecule adopts. For example, ground state, singlet excited state, the second singlet excited state, and third and fourth also are present for certain molecules. So, the molecule has its ground, electronic, vibrational and rotational energy levels. When it is in low energy state, it also exhibits S1, S2 as excited singlet states. These are maybe numerous, certain number for a molecule. So, each singlet level electronic energy level may be represented by S0, and these bold lines, these are vibrational energy levels, and the blue color filled in the lines is representing the rotational energy levels. So, S0 represents ground state, S1 represents excited singlet states. In the ground state, the electrons are paired, they have opposite spin, they are antiparallelly oriented. In the case of excited singlet state, one of the electron from the ground state is promoted from its bonding molecular orbital to anti-bonding molecular orbital. So, when the molecule absorbs radiant energy, its ground electronic energy level gets promoted into maybe up to S2, sometimes up to S1. So, there might be an internal conversion occur during the course of time in order to deactivate this energy level. So, the electron excited to its excited state, the time spent by the electron is short, it is short lived, that is 10 power minus 15 seconds. So, there might be internal conversion occur. During the course of internal conversion, so the energy levels may be diminished. The electron moves downward from S2 to S1 via loss of some energy. So, this process of loss of energy occur in many ways. For example, in the form of sound, in the form of heat, most probably in the form of emission of energy, radiant energy. If it is visible, we can see the liberated energy in the form of light. So, the process of absorption of energy to catch up S1, S2 is called excitation. The process of release of energy in the form of light from S1 to S0 is called fluorescence. Sometimes what may happen, the spin of the electron may be reversed while crossing from S1 to T1. This T1 is called excited triplet state. So, therefore, during this intersystem crossing, so the excited electron comes to the excited triplet state by changing its spin. So, afterwards the electron deactivates to its original ground state via liberation of energy. Sometimes it may be non-radiative relaxation, sometimes it may be radiative relaxation. That means it gives up the radiant energy in the form of light. This process of emission of light or emission of energy from triplet excited state to the ground state is known as phosphorescence. Likewise, there could happen many electronic transitions, that is excitations especially. Excitation means when the electron from ground electronic energy level to the first excited state. So, like this many electronic transitions happen, excitation process happen in molecules or some population of the molecule. As a result,